Hello and welcome, I'm your Code Monk, and in this video we're going to make the Deadeye ability from Red Dead Redemption 2. Let's begin. Okay, so here's the scene I have prepared. I have a player character, I can move around, and there are enemies being spawned, and I can shoot my weapon and kill them. Once they get shot, they fly away when they are dead. Okay, so this is the base that we're going to use. So over here is the player class. It is very simple. It simply deals with player movement and player shooting. You can check out the detailed video on the player movement with the simple character movement video, but it's still pretty simple. So on the update, I simply have a switch on state, and right now there's only one state, the normal state. So on case normal, we handle our movement. So the function down here simply tests for the keyboard input on the W, S, A, and D keys. It creates a movement direction using those keys and moves the player accordingly. Then on the update, we're also calling the handle aim shooting, and this again, it's simply getting the target position, which is the mouse wheel position. It sets the aim target to that target position, and when we press the left mouse button, if we can fire, then we fire and play the animation. So that's a very simple setup for the player class. Over here on this scene, I have a post-processing effect to simulate the Deadeye effect. I have set up all the values, and now in order to use the effect, all we need to do is modify the weight in here. So if it is on 0, it's completely disabled. These are the normal colors. And if I increase it up to 1, then it gets the complete effect. In order to set up the post-process, all we need is this post-process volume in here. And on the main camera, we also have a post-processing layer, and using that layer and so on. So again, all we need to do is modify the weight to go from 0 to 1. Okay. So let's begin by making a new C# script. This will be the Deadeye class. This will handle the effects and the state of the Deadeye. In here, let's make this a static function since we don't want to instantiate it. So make it static and remove the monobehavior references. This is going to be a very simple, clean class. So let's begin with a init function. This will receive the references that we're going to use. So a init, and in here, first let's receive the post-process volume that we're going to use to modify the weight. So in order to do that, we have to go up here and using the Unity engine.rendering.postprocessing. So now in here we can receive a post-process volume, and let's call it the black-white post-process volume. It isn't black and white, it's more of a sepia, but that's a good name for it. So in here, let's store it. So in this class, we're going to have two functions, one to start the Deadeye effect and one to end it. So let's begin with a public static void start, and then we're going to have a public static void end. Now on our start, let's simply enable the effect so we can see it in action. So we simply do the black-white post-process volume and set the weight to 1, and on the end, let's set the weight back to 0. Okay, so that's the effect. Now let's also make a public static bool is active to test if the effect is active. Okay, so this is our very simple Deadeye class. It has everything we need to start testing. So now let's go into the player class. And up here, after we test for the shooting and the movement, let's make another function. This one will be the handle Deadeye. So let's make in here private void handle Deadeye, and in here we're going to test for an input. Let's say keycode.e. So when we press E, let's toggle the Deadeye effect. So let's check if Deadeye, if it is active, then we do Deadeye.end. If it is not active, then we do Deadeye.start. Okay, so by pressing E, we should be able to toggle the Deadeye effect. And now finally, all we need is to go into the game handler. So in here, we have the code that is currently spawning the enemies. So let's add another serialized field. In here, we're going to receive the post-processing volume. And we're going to initialize the Deadeye class and give it this reference. Okay, so just like this, we have everything to be able to test. Okay, here's my character, everything looks normal, I can shoot and I can kill enemies. Okay, now if I press E, yep, there we go, the effect is active. And if I press E again, yep, now it's disabled. So enable, disable. Okay, great. So instead of enabling and disabling the effect instantly, let's add a slight animation. So here let me add a private static void, and I'm going to call this the animate black white effect. receive a float for the start, float for the end, and a float for the animation time. So in here we want to increase or decrease the weight starting at start, ending at end, and taking animate time to do the animation. So that's essentially a very simple lerp function, so let's do that. In order to do it, I'm going to use the function updater from the CodeMonkey utilities, which as always you can grab for free from unitycodemonkey.com. So I go up here using codemonkey.utils. So now I can go down here and use a function updater. This essentially lets me trigger an action on every update. So this action here will be triggered on every update. So now in here we want to set the black-white post-process volume and modify the weight. Now let's use mathf.lerp. We're going to start, going to have an end, and then we need a time value. So let's do up here a time, which starts at 0 and will end at 1. So in here, let's increase it by unscaled delta time, since we're also going to modify the normal time scale. And we simply divide it by the animate time. Okay. And finally, the function updater can receive an action which returns a boolean, and if that boolean is true, it destroys it. So in here we return time bigger than 1. So essentially, if time is bigger than 1, then the function updater will destroy itself. If not, it will keep running on every update. Okay, so now we can go up here, and on start, we want to animate. We want to start on 0f, we want to end on 1f, and let's say between 1 second. And on end, we do the same thing, except we go from 1 to 0. All right, so let's also do the same thing to animate the time scale. So in here, make animate time scale effect. And we're going to modify the time.time scale by that amount. So the time scale, if you don't know, as you can see, it is the scale at which the time is passing. So essentially, normal is at 1f, but if we want to do some slow motion effects, we can simply reduce this value. So in here, when we activate, let's put the game on slow motion at about 20%. So we animate the time scale effect. Let's start at 1f, at normal time. Then we're going to slow it down to 20%, and again do it over 1 second. Okay. And here we start at 0.2 and we end at 1. All right, so we can tweak these values, but it looks good for now. So again, let's test. Okay, so here I am, I can still move, I can shoot enemies, everything is fine. Now if I press E, yep, there you go, the effect is animated, and after a while it is full on, and the same thing for the time effect. As you can see, everything is on slow motion, I can shoot them, and everything works. Now if I press E, yep, everything goes back to normal after 1 second. Okay, so we need to make the time scale animation a bit faster, but everything else looks good. Okay, so now that we have the visuals working, let's deal with the Deadeye tags. So essentially in here, we want to add a bunch of positions, and then we finally shoot towards all of those positions. So in order to do that, let's first go into the player, and in here we want to add another state because we don't want him shooting whilst the Deadeye is active. So let's add the state Deadeye active. So in here, let's rename this to handle Deadeye activate, and here we are simply going to enable. And once we do, we set the state to state.Deadeye active. Okay. So now in here on the update, let's handle the other state. So in here, let's make a function to handle the tag. So handle Deadeye tagging. And now in here, we want to capture on mouse down. So if input.get mouse button down of the left mouse button, so button 0, and okay. So let's grab the target position, which is a vector3 for the target position, which we go into the utils class to get the mouse world position. So that's the position that we want to tag. So in order to do that, we have to be able to add tags on the Deadeye. So in here, let's make another function, a public static void try add tag. And this will receive a vector3 for the tag position. We're calling it try add tag, so we have a limit. So up here, let's make a private const int for the tag amount max, and let's say a maximum of 5 tags. Then we're going to need a private static list of vector3. This will be the tag position list. So in here, let's initialize the list, and down here, when we try to add the tag, if the tag position list.count, if it is less than the tag amount max, then here we can add the tag, so add the tag position to the tag position list. So now we can go back into the player, and here when we press the mouse button, we can go into the Deadeye class and try to add the tag, and this is the tag. So now we are successfully capturing all the various tag positions with a limit of 5. Now we need the player to receive that list when the Deadeye actually ends. So in order to do that, we're going to modify the Deadeye start class, and in here we're going to receive an action, which is on using system. So we're going to receive an action and we're going to call it on Deadeye end. And that action will receive a list of vector 3s. An action is a function, so in this case, the start will be called with a function on the parameters, and that function will receive a list of vector 3 as a parameter. So in order to do that, let's store this up here. So now on the end, after we do all of the effects, let's call this function using our tag position list. Okay, so now we can go back into the player, and in here on start, it expects a action that receives a list. So in here, let's make a private void on Deadeye end, and we're going to receive a list of vector 3. This will be the tag position list, and this function is what we're going to pass as an argument towards this function. Okay, so essentially when this function is called, we receive the tag position list, which contains a list of all the positions that were tagged. So in here, all we need to do is shoot towards every single one of them. So I'm going to do a for int e equals 0, going to cycle through the tag position list.count. Now in here, I got a vector 3 for the tag position. So now I want to shoot this tag. Now obviously I don't want to shoot all the positions at the same time, so I want there to be a little delay. So in order to do that, I'm going to use the function timer, which again, part of the CodeMonkey utilities. So this lets me easily trigger an action after some time. So we're going to fire towards a tag using the same pistol fire rate that we use normally. So in here, let's trigger an action after fire rate multiplied by the index. And here we simply do the same thing for the shoot target. So we shoot this tag position after fire rate times I. So essentially the first tag position will essentially fire instantly because it will fire this action at fire rate times 0, which is 0, so it will execute instantly. Then the second one will fire towards the second tag position after fire rate multiplied by 1. So the fire rate is at 200 milliseconds, so it will fire at the first tag position, and 200 milliseconds later it will fire at the second, and so on. Okay, so the last thing we need is to actually deactivate the Deadeye to call Deadeye.end. So let's go up here, handle Deadeye end, and here let's make a private void handle Deadeye end, and we're going to do essentially the same thing as in here, except instead of start, we're going to trigger the end, and we're going to bring the state back to normal. Okay, so let's see if all of this is correct. Okay, so here I am, I'm walking around, I can still shoot, I can do everything, and now if I press E, yep, there you go, the effect starts and it's on slow motion. Now I can click on various positions, so click here, here, and here. Now if I press E, yep, shoot, shoot, shoot. Yep, there you go, he fired into all the positions exactly as we wanted. So again, let's go into Deadeye and shoot down, and now actually there won't be an issue, so let's see. Yep, there you go, he actually fired 5 or 6 shots. So that's because we are not clearing the list. And if you can also see, we also have an issue with the animation, which is we click here, then we are aiming in there and check out the weapon, and there you go, the weapon is not looking into the correct position. So essentially we want to still block the normal aiming and movement until the effect is completed, but after that everything is fine. Okay, so first to fix the animation, so in here when we press to end the Deadeye, we check if Deadeye dot is active. If it is active, then we end it, and that's it. We don't modify the state. Instead, we modify the state down here, where we add another function timer after the fire rate dot count. So after every tag position has been shot, then we are going to execute an action, and that action will set the state back to normal. Okay, so this solves the animation issue. Now again on the Deadeye, in here on start, we have to reset the tag position list. So it's very simple, just here dot clear this list. Okay, so let's see if those issues have been solved. Okay, here I am again, walking around naming, perfectly fine. Okay, now if I press E, yep, there you go, slow motion, everything. Now I shoot there, and click, shoot, shoot, shoot. Yep, there you go, the animation of the pistol was correct. Now it's back to normal. So again, let's see if it no longer saved the previous one. So again, back into Deadeye. I'm going to shoot in here, and he should only fire 2 shots. 1, 2. Yep, there you go. Okay, great. So the effect is pretty much working right now. Now, the only thing we need, obviously, is to actually see where we are actually tagging. So we need to be able to view all the tags that have already been created. So let's do that. So over here on the Deadeye class, let's create a inner class to deal with each specific Deadeye tag. So in here, let's make a public class, and let's call this Deadeye tag. This will represent a single tag. So in here, let's make a constructor, and we're going to receive a vector3 for the tag position, and we're going to store it internally. And now let's simply have a public vector3 to get the position, which will return the tag position. Okay, so now we have a nice object that is responsible for each tag. So using that, we can go up here and essentially clean up our code. Instead of having a list of tag positions, we're going to have a list of Deadeye tags. So let's rename this to Deadeye tag list. So down here, when we are adding a tag, instead of adding a tag position, we're going to add a new Deadeye tag using this tag position. Okay. And on Deadeye end, up here, let's calculate the list of vector3 for the tag position list, since that is what we want to pass back to our player. So make a new list and now cycle through all of the Deadeye tags. Okay, so we have reworked the code to work with a specific Deadeye tag object, but everything else should still be working. The player is still receiving a list of vector3s. Okay, so now let's deal with making the UI visual. So over here on my canvas, I'm going to create an empty game object, and I'm going to name this the Deadeye UI. And inside, I'm going to add a UI image, which will contain the cross image that I have in here. So let's just tint it in red and make it a good size. Okay, so this is our cross. Now let's name this into the cross template. This is the template that we're going to duplicate. So let's make the script to handle the UI. So in here, let's make a new C# script, the Deadeye UI. And inside, we're going to have a function, a public static void add tag, and this will receive a Deadeye.Deadeye tag, Deadeye tag. In order to use the static, let's store our instance. So private static.UI for the instance. So in here, let's also grab a reference to the transform for the tag template transform. So in here, let's actually rename this to add tag static, which will do an instance add tag. And here we have a private void add tag, which will receive the same thing. So in here, the first thing we want to do is duplicate our template. So now we have our duplicated tag transform, and now we need to actually position it where it should be. So essentially, we need to convert our Deadeye tag position, which is a world position, into a UI position. So in here we have a vector3 for the tag world position, which is the Deadeye tag.getPosition. So this is the position in the world. So we take that and we do a camera.main.world to screen point. So we convert that world position into a screen position. So a vector3 for the screen point. Now we want to convert the screen point into the UI point. So we grab a vector3 for the UI world point, which will be the UI camera. That's what we're going to need a reference to, and do screen to world point of the screen point. So here, let's add a private camera for the UI camera, since we need that reference. So now we have the UI world point, so all we need is to convert into a local point. So a vector3 for the UI point, which will be the transform dot inverse transform point. So we take a world space and put it into a local space. So we do that using the UI world point. And then we simply set the tag transform dot local position. Set the local position to be at this UI point. And since the UI is on a different Z, then let's simply reset the Z. Okay. So again, the Deadeye tag contains a world position up here on the get position. So we get the world position. Since the camera and the UI camera are different, we need to convert the position between one and the other. So we convert from a world position into a screen position based on what the main camera is seeing. So that gives us a position within somewhere in our screen bounds. So taking that screen position, then we use the UI camera to convert the screen into a world point using the perspective of the UI camera. And then using that world point, we convert it into a local point on this transform, and that's where we're going to place it. Okay, so now we can go back into the Deadeye class. And here when we are trying to add the tag, we create a new Deadeye tag. And after adding it to the list, let's also go into the Deadeye UI. And we're going to add tag static, and we're going to pass in this tag. So we call this, and then this one calls this function, which instantiates the tag transform, and so on and so forth. Okay, so let's see that in action. Okay, here I am, everything is normal. Now if I press E, Deadeye is now active. Now if I click, yep, there you go, there's the tag position. Now I click in here, and yep, it is spawning all of the correct positions in the correct point. And as you can see, they are limited to 5 tags. Now, as you can also see, the position is correct where I clicked, but it is not accompanying when the camera actually moves. So we need to update the position on every frame. So let's do that. So in here, let's make an inner class to deal with each specific UI object. So in here, I'm going to have a constructor, and in that constructor, I'm going to receive a Deadeye.Deadeye tag. And I'm also going to receive the transform. So then let's make a public void update, which will update the position of this Deadeye tag. So essentially we're going to copy all of this code. Instead of running it just when it's instantiated, we're going to run it every time. Okay, so now up here, when we are adding the tag, let's create a Deadeye tag UI object. Give it the Deadeye tag, the newly created tag transform. So now essentially everything is working exactly the same as previously. It is only being updated on start. So we need to go up here and make a list. We need a private list of Deadeye tag UI object. And here we want to add this to the list. And on the main UI, we can now do a private void update since this is a mono behavior. And in here, we simply cycle through all of the objects. And we call Deadeye object.update. Okay, so on every update, we are calling this update function, which this update function is doing everything we did previously. So it gets the tag position and it converts into world to UI point. So let's see if all of our tags are updating their position. Okay, so here I am going to enable Deadeye. Okay, now I'm going to click right on top of this bush. And yep, there you go. If I move the camera, you can see that the tag is always on the same position. Now I click on this one, and now I stop. And yep, there you go. He fired into all the positions. Okay, great. And as you can see, they are still tracking. But obviously, when the Deadeye is ended, that cross should be destroyed. So let's do that. So up here, let's make a public static void destroy all tags. And here I'm going to cycle through all of the tags in my list. And I'm going to tell the tag to destroy itself. So now let's go down here and make a destroy self function. So all we need to do is to call the destroy into the transform.game object. And up here, let's also clear the list. So clear the UI tag object list. Okay, so now let's call this over here on the Deadeye when the Deadeye is over. And here when it's false, we go into Deadeye UI and call the destroy all tags. Okay, so let's see. So enable Deadeye, tag in here, here, and here, and now click E, and there you go. He fired into all, and all the tags have vanished. Okay, great. Now there is still one thing that we need to do, which is if I enable it, and now I click on this one right here, you can see that the tag stays in the position. Whereas in the game itself, when you click on top of an enemy, the tag actually follows that enemy. So in this case, if I click on an enemy and then he moves away, then I wouldn't hit him. So let's deal with that. So over here on the player class, when we have Deadeye active, we are calling the Deadeye tagging, and it's in here that we are adding new tags. So it's in here that we need to check if we are clicking on top of an enemy or not. So in order to test that, we can simply do physics2d, do an overlap point. We're going to test on the target position. This function returns a collider2d, which is a collider on this position. So the first thing we need to do is test if the collider is not null, then we have actually clicked on something. So if we have clicked on something, then we want to check if that something is an enemy. So in order to do that, we can simply use a dummy component to tag our enemies. So in here, let's make a new C# script and call this Deadeye taggable. This will be just a completely empty mono behavior. So I have here the enemy prefab, which as you can see has a box collider and then the enemy scripts. And I'm simply going to drag this component onto it. Again, it's a completely empty component. So now using that, we can go back into our player class. And over here, if we do have a collider, then we get that collider.gameObject getComponent Deadeye taggable. So if that component, if it is not null, then that means this collider, the game object that this collider is on, also has Deadeye taggable, so we can assume that it is our enemy. So now that we know that, we need to know the local position that we have clicked. So define a vector3 for the local tag position. So that position is on the collider.transform.inverse transform point. So this converts from world space into local space, and we want to do that using the target position. So this will give us a local target position local to the enemy transform. So if we click exactly on top of the enemy transform, then this will be on 0, 0. If we click slightly above, then this will be something like 0, 1. So now all we need is to be able to add a tag that actually updates its position every time. So we need essentially to create a func which will return a vector3, and this will be the tag position func, which will essentially return the transform.position plus the local tag position. So whenever the transform position changes, then this whole return value will also change. So then we need to be able to send that into our Deadeye system. So we need to modify it to be able to receive a func that receives this. So over here on the triad tag, instead of receiving the tag position, let's receive a func. And that func is also what we're going to pass into the Deadeye tag. So let's go into the Deadeye tag. Instead of receiving a straight position, we'll receive a func and do everything. And on the Deadeye tag position, we can simply return the return value of this func. So just like that, since all of the other code already goes through this function, then everything already works perfectly fine. So in here, we're trying to add a tag using that, and we create a new tag object, and the rest of the system works with that object. So now we can go back into the player and deal with the other options. So in here, if the collider is null, so if we click on nothing, then we want to send the same target position as previously. So we're going to send in a func, which will always return the target position. And the same thing up here, in case we click on something, but that something does not have the Deadeye taggable, then we send the same target position. Okay, so if we click on something, we send with a function that will always update whenever the transform changes. And when we don't, we simply send a fixed value. Okay, so let's see if our tags are moving along with our enemies. Okay, so here I am, enemies are moving, and I enable Deadeye, and now I click in here, and there you can see it's static. Now if I click on that one, yep, there you go. It is accompanying the enemy, and the same thing for that one, same thing for that one. And I click on various positions, and I can't do any more. Now I click on E, first shoot there, 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 and yep, there you go. He fired into every position. Again, enable, shoot that one, that one, that one, and that one. Boom, 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 boom. Yep, exactly. So I can shoot into various empty positions, and also with an object that goes along with that object. And just like that. So there you have it, we created the Deadeye ability from Red Dead Redemption 2. As always, you can download the project files and utilities from unitycodemonkey.com. If you have any questions, post them in the comments and I'll do my best to answer them. Subscribe for more videos, and I'll see you next time.